Alright, so let's go ahead and we'll do the Wireshark. Okay, so we already completed that, and whoop whoop, our streak is now 2. Heads up for us. We're coming up in it. Okay, so installation of Wireshark. Okay, Wireshark already comes with Kali Linux. Wireshark also comes with GNS3. Super easy to install. Alright, let's see what we got here. The first screen you're greeted with. Yes, sir. Yep, that looks like it. Alright, if you've never played with Wireshark before, this is definitely something you want to read and look at. Collection methods. Bunch of different collection methods that we can do. Okay, network taps, MAC flubs are poisoning, filtering, captures. So that's like we're going to say, like, we're going to just look for a certain thing. Alright, so we got our different operators, things like that there, which I'm not like really like the best with, but you can usually figure them out. Wireshark can usually help you out with it, and you can also look it up usually. Okay, and this is also your packet details, so your OSI layer. People do not teach stupid people acronyms. There's also a pizza one too. I forget what the pizza one is, but that one starts from the top to bottom. It's like pepperoni or pizza, something like that. Okay, so let's go ahead and download these task files like right here. We'll save that, okay, and we'll make a directory cd back. Make a directory for Wireshark. Wireshark 101. CD into there, and we'll move from downloads. Look for that pcap file now, aren't we? Oh man, we got a couple of pcap files in here. Is that it? I don't know what this pcap file is called. Download task files. What are you called? MV6 startup. Okay, MV6 something. Okay, let's go ahead and I should probably start looking into deleting a lot of stuff. NB6 startup pcap. Okay, cool. So right here, and we go ahead and do a Wireshark for that NB6 startup pcap, and there we go. Okay. Ooh, we got something a little bit different in here. Okay. DHCP, ARP, DHCP, syslog, DNS, TCP. Cool. So what does it want us to look for here? ARP traffic. Okay, so what is the opcode for packet 6? Oh, so let's go ahead and head up to packet 6 here. I don't know what's asking about opcode. I don't know what it means by that. What do you mean by what is the opcode? Never heard of that. So let's look it up. Opcode Wireshark. Filtering packets by opcodes. It's the first hexa component of the payload. I feel like we're stretching for stuff now. Like we want to make up a new word. Yeah, what is the opcode? Opcode. Okay, so it actually has opcode on there. Literally, I've never heard of that. If anyone can in the chat can tell me what opcode is, that'd be sweet. I've never heard of that. So we got our source, boom, our trailer, our ARP request, like right here. I also don't know how easy this is for you guys to read. That's probably pretty big. Opcode request 1. Is that what's asking me? No. What is the opcode for packet 6? Opcode request 1. Right click. Can we follow that? No. I don't know. Like I've literally never heard of opcode. And I've been doing this for quite a while. I've never heard of anyone refer to anything as an opcode. Opcode. Okay. What is the source MAC address of packet 19? We can get that pretty easily. So we'll go down to packet 19, and source MAC address is going to be like right here. Plus that at the beginning is how does it want it also? Okay, it wants it like that. Alright, so we can come down to source MAC address. From there we can definitely look everything up that we need to. There it is. There's the sender MAC address. Well, we can look up our source. There it is, like right there, 80FB. So we can go ahead and copy the value, I believe it would be. I believe we want to copy the value, I don't know. Yep, there we go, we'll submit that. Okay, what 4 packets are reply packets? This is going, this is getting pretty hard from the very beginning. I figured it's going to be like, what is HTTP? We got SIP in here. Holy shit. Okay, we got a lot of stuff in here. We're gonna have to actually break this down for like a second. We're gonna have to actually stop, collaborate, and listen, and actually look at this guy like real quick. You know what I'm saying? So we're gonna have to actually do something like that. And I'm about to give myself like a minute. All right. So let's go ahead and pack 6, right? There we go. Okay. Opcode is request 1001. I don't know what's asking me like right there, but I'm sure we can figure it out. Right? Opcode request 1. Wants 3. You know what? Is it like this? I was looking at 3 on the right hand side. Yes, it is. What are the 4 packets for reply packets? Okay, so now we got to think of reply packets, right? So first, what gets replied to? There's 1, I think. 2, 3, I think. 4. Yeah, it has to be something like that. Like, is 519 one of them? Yeah, it is. Request 1. Yeah, I was thinking like, yeah. Okay, so how do we know that, right? Let's go ahead and go by source. Okay, that's what we're doing like right now. Is we're going by source. Okay, so we're looking at the sources are different here, right? So he's obviously replying back to this over here. Okay, so he's asking who has that, right? So he's obviously replying back. Although that was a broadcast, I don't know if I really call it reply. That's kind of alright, but he's replying back to the guy that's been sending it out the whole time. So we got 74, 399, 74, 399, 458, 519. 458, 519. What is the IP? What do you mean? 74, 399, 458, 519. That should be all of them. Okay, so let's go ahead and ARP. Opcode is a request. It's not a reply. Oh my god, is 520 a reply? Where's 520 at? Are you the reply? Is it just 1 up each time since that's a request? Reply, opcode reply. Okay, so we could do something with this also since I just figured out what opcode is. Let's try ARP. Is the opcode in here? Opcode isn't here. Okay. Equals 2, right? Because it's gonna be 1 up. Because how did we figure that out, right? So we looked at it and we saw the one was request, the other one was reply, right? So we got the opcode reply is 2. Okay, so now we're going to do an ARP opcode equals 2, which is going to be 1 above every single thing we just put in there, because that would be the reply, because the other ones are the request. Duh. We could just actually broken that down, and I could have just stopped being an idiot. Either one of those would work. Me stop being an idiot, or, you know. So 76. That one would have been confusing though. 400. 459 and 520. Submit that, and there we go. Okay, so what IP address is at 80FB? And then we got up here. Yeah, that's this guy like right here then. That 80FB should be this guy like right here. Right, so now we need to find a layer 3 packet though. Never mind, it's right there. 10.251.23.1. I figured we would need like a layer 3 packet, but I guess not. Alright, cool. So we are done with that one. ICMP traffic. Oh crap. Pings. Pings everywhere. I'm not about this life. DNS plus ICMP, okay? What? What are you doing? Stop doing whatever you're doing, stop. Oh, open with Wireshark. No, I don't want to do that. Okay, PCAP. DNS plus ICMP. Okay. So we'll go ahead and move him over into here. So we'll do a move from download, right? And that was DNS. Boom. Move him like right here. Boom. Please stop there. Okay. And then we'll do a Wireshark for that one, DNS. Now, did you notice that one of them is PCAP-ng and the other one is PCAP? PCAP-ng, I believe that was the newer ones. I believe it is. I believe that one's newer ones. Is PCAP-ng. Okay, so we have ping here and we have DNS. Yes, we do. Okay, this one's not nearly as big, thank God. Alright, so what do we got here? Alright, boom, 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 boom. What is the type of packet? What is the type for packet 4? Okay, well we can go ahead and look at that like real quick. Let's go ahead and look at packet 4. We want to see the type, and that should be 8, which is an echo. Alright, cool. So we'll say that's an 8. What is the type for packet 5? It's probably going to be a reply. Oh, type 0, echo, ping, yep, reply. So that's a 0. What is the timestamp for packet 12? Only including month, day, and year. No, Wireshark bases its time off your device's time zone. If your answer is wrong, try 1 day more or less. Crap. Because I am in Japan. So that's going to be even worse, I feel like. Okay. So we can try this one. Alright, so what is the timestamp for 12? Let's go ahead and hop into packet 12 down here. And we do have our timestamp, May 30th, 2013. Let's try it. However, it should be, since we downloaded it, it should be going off of his. Yeah, I must say, it should be going off of his. So that shouldn't matter, like right there. What is the full data string for packet 18? Let's check it out. See what packet 18 is doing. ICMP. The full data string for packet 18 data is whatever this is, like right here. Right click, copy, value. And there we go. Boom. Alright, TCP traffic, which looks like we're still going to be the same guy here, I believe. And I might take a little 5-minute break here. Not even. Maybe like a 2-minute break or something like that. But we do have some TCP stuff in here, okay. And then I'm going to go with read the above and move into task 10. Okay, so TCP traffic, like TCP IP, 3-way handshake, SYN, SYNAC, ACK. If you've done anything with networking, Network Plus, CCNA, anything like that, you'll know what that is. So let's go ahead and download these task files with DNS, save file. This one's called DNS plus ICMP, okay. Same thing I just literally had. Yeah. I'm also in JSON link right now by accident. It's the same exact thing. Alright, so we're right back into here again, because I believe, pretty sure we downloaded the same exact thing twice. And we got this again, right? So let's go ahead and check this out. DNS query. Yep, okay, so what is being queried in packet 1? Okay, so we can see like right here, we have our queries inside of our DNS server, like right there. So what is being queried in packet 1? Let's go ahead and let's find out. Packet 1, DNS, domain name service query, queries, type PTR class in. What is the question now? What is being queried in packet 1? 8888, and then something. 8888, 8888, 8888, it's gonna be this mic right here. It's Halloween time, right? That's pretty good. So with that, what is being queried in packet 26? That's a good question. This guy asked a lot of good questions. Queries, Wireshark, name wireshark.org. Is that what it's looking for? What is the transaction ID for packet 26? Transaction ID? Ooh, I don't exactly remember where that's at. Transaction ID, there we go, okay. Copy value. Also, just so everyone knows, if you really want to get hardcore with Wireshark, David Bumball actually has a class on this stuff like right here. It's really, really good. And he actually goes super deep into Wireshark. Just so you guys know, you can get it for free sometimes also. I actually sent out for free the other day in my Discord chat. But yeah, he has it for free sometimes also, and yeah, he has some really, really, really good stuff. HTTP.cap, let's go ahead and grab him. You notice that it's all PCAS file. We're just changing the name of everything, right? Save file, okay. So let's go ahead and move this one to HTTP.cap, right? Move that over here. And let's go ahead and Wireshark.cap. Ooh, and yes, we do have some HTTP. Alright, well, we had an ad, huh? There's the ad like right here, huh? HTTP, we actually see what they're actually doing here. We can follow that in stream also, follow in HTTP stream. If they were setting up like a reverse shell, something like that, if you guys are doing anything like that, this will actually show in here like exactly what reverse shell they use and stuff. It's actually one of the try hack me's actually do that in. Pretty cool, like a little thing. Alright, let's go ahead and see what we're doing here. What percent of packets originate from the domain name server? Having statistics protocol hierarchy. I don't know, you can do this. Statistics protocol hierarchy. So what percentage of packets originate from the domain name server? 4.7? Is that what's asking me? I hope. I really, really, really hope. What endpoint ends in .237? What endpoint ends in well, there's .237. What endpoint? .237. What endpoint ends in .237, right? Is it? Oh, what endpoint? Just like what IP address? Like 145.254.160? 145.254.160.237. Okay. What is the user agent listed in packet 4? The user agent, huh? That's the one I actually grabbed. Wahahaha. Obviously that's the one, but still. Whoa, what is the user agent? Should be like Mozilla or whatever? Like this guy, user agent, yeah. Okay, right click, copy. Copy the value. I already grabbed him. Looking at the dash stream was the full request URI for packet 18. Ooh. Let's take a look at it. Packet 18. Hop back over into here. Packet 18. Full request URI, huh? Double click on him. And scroll down like a little bit. That one's truncated. If it was truncated, I don't actually get to see the whole thing, right? Is this one not truncated? Copy the value. Can I do that? That's the get request like right there, so maybe. That was the value. Oh, Poops McGee. Okay, now we just gotta try to figure out how to actually copy that guy down. Does it matter if he's truncated? I don't understand. Copy value? Just copy the field name maybe? Okay, there we go. Submit. Okay, we gotta get rid of this get truncated. Like that? Like that? Oh crap. Okay, what we got here? It can't be HTTPS. That's possible because it's HTTP, right? But this guy's showing like that. Yeah, I'll say it can't be that, like right there. Oh, has to be HTTP, but this guy is showing that it's bigger than that. See? HTTP. And now I'm missing a little something like right there. What the heck? He's broken. That's all. There's nothing else we can do about it. Man, I got way too many of these guys open, huh? How did Wireshark go? There we go. Okay, so I was looking for this one, right? Packet 18 or whatever. And then we went down and it said, what is the little thing for, right? And that's what it is, like right there. But the problem is I can't actually type that in. Anybody got any ideas on what to do about this? Is there like a hint? Yeah, is there like a, hey, like, no, look at the dash stream, was the full request URI for packet 18. And we definitely got the full request URI for packet 18. So I'm not really understanding what it's asking me. Is it the one that's down here? There should be another one actually. It should be like, where's that? Request URI, request URI, request URI. We should actually have something that actually says full request, HTTP request. Full request URI. So there it is, like right there. That is the full request URI, like right there. There's nothing I can do about that. On page 18, right? Boom, boom. Full request URI. Full request URI. Page add to, right click, copy. Copy the value. Control V. For some reason this one got longer again. Okay, that was weird. Okay. What domain name was requested for packet 38? Alright. What domain name was requested for packet 38? I don't know. Let's find out. XML. It should be Earthreal or whatever. That should be the domain name. I think that was requested like right there because it's asking request URI. It's asking to download something from there. So I think it would be that. We could try to throw that in there, but yeah, I think it's earthreal.com or whatever. I think it's going to be just that. Yep. Look at a data stream. What is the full request URI from packet 38, which is what I actually just threw in there, so it should be that. Okay, cool. So HTTPS traffic. We are almost through this guy, huh? We're actually moving right along here, aren't we? Let's download those task files. And this one's called snakeoil2.zip. What? Well, I don't know if I really want to download something called snakeoil2.zip. Let's go ahead and grab it. We'll zip in and see what we get. Okay, save file, okay. Downloads snakeoil2.zip right here, unzip snakeoil2.zip. Then we get our PCAP file, Wireshark, RSA snakeoil2.cap. And there we go. Okay, cool. So here's our file like right here for HTTPS. Looks like SSL version 3 is what it looks like we got here. And let's go ahead and check out what do we got here, right? HTTPS traffic. What do I want to know? How about that? Look at the dash stream was full request URI for packet 31. It's going to be HTTPS something. Packet 31. You have to see how everything has changed now also. Do I have to like decrypt this? Does it actually teach us how to decrypt it? I think I have to decrypt this. Maybe I should actually read what it's actually trying to tell us on. Yeah, we have to decrypt this guy. Should be a preferences or something like that. RSA key, navigate to edit preferences, protocols. Okay. So that's exactly what we're going to do. We're going to go to edit, preferences, RSA keys, add new key file or add new token. I feel like add new key file. Key file, okay. Say add new key file. Yep, that one actually, exactly that. Okay. And that should decrypt everything, I think. Now that we have our same import, why shall we go back to the pack cacher dash stream? I think it should unencrypt everything. That still looks pretty damn encrypted to me though. Close. Did I mess this up? Preferences, RSA keys, boom, boom, boom. And new token. Okay. Protocols, the thing I gotta make is actually so I have to like exit out here, like hop back into them or something. Maybe I have to do something like that, huh? Well, now it's saying HTTP, so did that work? Fully alright, HTTPS, yeah, maybe not. I don't know. Just doesn't actually send it over some type of data. There's a key exchange. Let's look at what it wants to look at first. It said to look at packet 31, huh? So we gotta look at packet 31 like right now. That's what it wants us to look at. Let's go ahead and check that out. Packet 31. Okay, cool. Yeah, we're good. Right click. And what did it want us to actually look at here? Was the full request URI, which is exactly what I was looking at, right? Where'd it go? There you are. Copy, and we'll do copy that value. Looking at the data stream was full request URI for packet 50. Packet 50, okay. Full request URI value, boom. And we go and copy that value. And was the user agent listed in packet 50, which should be right back up here. User agent, boom, copy that value. Surprised we haven't done anything like pictures or anything like that. Pictures or voice or video or anything like that. Analyzing exploit PCAPs. Conclusion. Oh, that was a good one. I did like it. There was a couple of things I've never done before in there. I do wish we had a couple more things. I wish there were some questions in this one. So just completed. But yeah, that was a good one. There was quite a few things that I learned in there. There is a bunch of things you can do in Wireshark. Like I said, David Ball's class usually is free every once in a while. It's on Udemy, Udemy, however you want to call it. That is a great Wireshark class. The first like 5 minutes in the class, you'll be like, whoa, because they do actually intercept the phone call and then play the phone call back. So, and it was actually something I've actually wanted to do for a box for a while now. I just need to figure out how to get VoIP working on my Windows machines, for Windows 10 machines, free. Because I'm not going to, pay a bunch of money just to do that. So that was the one thing that I really want to look at is that. But yeah, other than that, that's gonna be about it for tonight. And I'm gonna keep messing with the lab and everything. Keep messing with that and see if we can build more stuff off of that, and see what else we can do with it. See if we can do some, intercepting, use a repeater, things like that, and be able to intercept packets and stuff as they come through and crack those hashes, and maybe do. I don't know if we're gonna be able to do a pass the hash or something, since we're using NTLM nowadays, but we'll see what we can do. Alright, you guys have a good one, have a good night, and I will talk to you all later.